The other day, I asked my 12-year-old daughter, Linda, for recommendations on drawing software. And Linda was like, well, okay, so there's this one that's free, I think it was Fire Alpaca, and it's pretty good, it updates a lot. And then she talked about a couple more, and one of them was like, I think you even had to pay for it. And she's like, and it hardly ever updates, it's no good at all. I like that the next generation recognizes that good software updates. Good software continues to grow with you. As opposed to, the other day I went to Micro Center, which is a fantastic computer store, but oh my gosh, they've got like this software that you need to like type your info in to sign up to get in the line to get service, and it's at least 10 years ago. It's like clearly this was very modern when it was new, and it hasn't been touched since. And it's like, no touchscreen, you have to use the mouse. And then when you get to the end of it, it's like, okay, thanks, Jessica, you're done. And then the next button says make reservation. And it's like, no, that's not what I wanted. That's for the next person. It needs to say like, okay or done. Why has it been this crappy for this long? Not impressed. And then I go and I get in my car and I put it in reverse, and of course the reverse camera shows up on the same screen that works the radio. So heaven forbid you want to operate the radio while you're in reverse. Now there's a separate knob for volume and push, right? There's a hardware knob for that. But does it work while you're in reverse? No, you must stare at this camera and ignore the radio. And that would be okay, except that it starts the radio by itself, right? You turn the car on and it picks somebody's phone and it picks its favorite song and starts playing it at whatever the heck volume, and you cannot change that while you're in reverse. All right, I am not angry that they ship the software that way. Nobody gets everything right the first time. I am angry that this is a 2016 vehicle. Not cool. What have they been doing for 4 years that I'm still suffering from this? Software is not done when it's released. Software is done when it's out of production. And you're like, oh, well, no, I mean, we're done. We're not developing on this. This project is done and it's still running. Isn't that great? No! That's a zombie, okay? Done is death, and that is the only done there is in humans and in software. That wedding is not a happy ending, that is a beginning. There is no done except death, and in software that means being out of production. So if your software is running and it's not changing, it's a zombie, and it's just gonna keep doing the same thing for years and years until it either trips over or eats your face. Software, at least any software that interacts with people, needs to stay alive. And to be alive, it needs to be learning. Just like people. To stay alive, keep learning to keep living. That's the trick. And for software to do that, okay, clearly we need continuous delivery for that, or at least automated delivery, certainly. So we need some tools around the software that make this easy, because if it's not easy, we're never gonna change it, and it's gonna be dead and wandering around out there creepily. But it needs more than that. The software needs to be alive in a person's head. And that person was probably one of the same people on the initial implementation or the last big push of changes, because this person understands like what that text means and can at least find where it is to update it, or how to change the radio so that it does listen to the volume knob when you're in reverse. But not a person, not just one person, because that's not resilient. There's no resilience in a single human, there's resilience in a team. So for software to stay alive, it needs a team around it. The unit of delivery is the team. When I picture a software team, this is a living system. People are alive, the code is alive, the system as a whole is alive, and it's constantly learning from each other. The code learns from us because we change it. We learn from the code when it throws exceptions or changes data or via feedback from the users. And all of that happens through our tools, through source control, through our editors, through our logging and our observability and everything like that. So the tools are part of this system too. And this is a system that's all about mutual learning. We live and we grow by learning within and among the system. The word for this is Samantha-C. Whoops. No, go back. No, go back. No, you can no, go back. No, go back. No, go back. All right. Hold on a sec. PowerPoint, you are my enemy today.
Software.
Yeah. There is no rollback, right? Not on an auto. There is restart, though. Okay, let's click for a minute. The word is Samantha-C. I really want that word on the screen because it's a very difficult word. It's from the Latin sim together and matha-C learning. It was coined by Nora Bateson, who's an anthropologist, and she was talking about ecosystems and economies, but it's even more so, there it is, okay. It's even more so in a software team. It's all about the learning. That's how the software stays alive and how the team stays alive. Okay, so in our Samantha-C, which is alive and learning, how do we keep the software alive without just sitting there and staring at the same piece of software all the time? Because if we're going to keep responsibility for every software that we put in production, as long as it's production, well, we don't want to get bored. We want to continue to also do new things. Changes will slow down. Software is kind of like gardening, and you want to continue to care for the plants that have produced valuable fruit year after year, and also plant new plants this year. So how do we increase our capacity for that? Well, we can look at some of the properties of code that's easy to keep alive. It's consistent and modern, and for it to be readable to us, it needs to be in our current idioms and styles and libraries. It's deployed regularly. What you don't want is when you go back and somebody's like, oh, just make this simple text change. And you make the simple text change in the simple code file. And then you go to ship it, and the build is broken. Maybe the tests don't work anymore. And even if you get past that, there's like a deploy gate that's doing security checks. And you're on old versions of the library, which have security problems, so you can't even deploy. And then if you update those, well, you need to upgrade your version of Node to get the latest versions. And oh my gosh, it's never going to happen. You're just going to let it shamble along with the security problems and all, because you can't deploy it. So you need to be doing that regularly. Those library updates and modernizations need to be business as usual. And then you'll deploy every week whether you need it or not, and you'll know when the deployment breaks. And then that software can stay alive. It also needs to be observable. It needs to give you feedback so that you can learn from it. It needs to emit events, so you have to bring its telemetry up to date and stuff like that. More interesting, we can look at the properties of the people in this system. This requires stable teams. You need continuity of knowledge because the people need to know not just the tech and the system as a whole, but why it's there. What is the purpose of the system and who is going to be impacted when we change this text or fiddle with this knob? And then you need contact with the customers or customer service, and then you can find out whether it worked. That's how we learn. We can also look at the properties of the relationship between the people and the code. And we can see that this team has ownership over the code, and they have good communication between them. The people are responsible for the code, and the code is accountable to the people. And by accountable, I specifically mean able to be held to account, as in able to tell the story of what happened, what decisions were made, and why. And that gets into really good events. So it's a relationship with high communication and ownership and caring. And then we can look at the environment that can support such a relationship. Okay, it's connected, as in the team talks to either the people who use the software, they talk to customer service. This does not involve going through or maybe they even have to go through the car dealer to find out what's going on. The funding model matters. If your company does accounting for software as a capital expenditure that must be done at the end of the year and is thereby deprecated over 10 years as an investment, I'm sorry, you're screwed. You can't do living software with the capital expenditure model. Now, some companies, the software management will like shield you somehow and make some fictions. Software needs to be a profit center and it needs to be an operating expense so that you can have a company that's powered by software instead of subject to its software. And finally, I mean, the scary thing is the team needs space to spend some time caring for the valuable flowering plants in its responsibility. It can't be all about when is this new feature going to be done. If the only question that management asks is when is this feature going to be done, nobody's going to spend any time improving themselves, existing software, or anything else. We have to ask, what are y'all working on, and what are you doing to improve, and how has the existing valuable software improved, and how do you know that's helped? We have to change the questions that we ask. So the environment matters a lot. There's only so much software that a team can support. Now, I'm not going to say that there's only so much a team can do in the time available, because doing is not our limitation. Time is only indirectly a limitation. The limitation of a team isn't what we can type. That's not our job. You can tell because we don't type all day, and most of what we type we delete. A limitation is how much we can know, because our job is making decisions. It's deciding what to type. What should we make the software do next? And how can we do that without breaking anything? So the limitation on a team is cognitive load. It's the knowledge that we need to make those decisions. Team topologies, I just finished reading this the other day. Excellent book, expresses this really, really well. The unit of delivery is the team, and the limitation of the team is cognitive load. How much do we have to know to do our job well? Because as the software gets broader, we have to know more. There are 3 categories of cognitive load. The first one is germane. You want this. This is the business logic. This is the complexity that we are encapsulating in our software in order to make lives easier for the people who use it. This is where the value is. You want complexity here. You want to spend as much as possible of your available cognitive load on this, the germane knowledge. You can help reduce what's necessary or make this go farther if you divide the software by team according to business domain. So if one team is maintaining a bunch of software for, I don't know, invoicing, then that business knowledge can go farther in terms of what they can support. Okay, category 2, intrinsic cognitive load. This is essential to the task at hand. We take this business complexity and we encode it into the computer. We need to know our software language, or our programming language. We need to know the frameworks. We need to know the quirks and intricacies of the systems that we integrate with. That is necessary. We need to, if it's a web app, we need to know how the browser works. And if it's on the JVM, we probably need to understand something about garbage collecting sometimes. Things like that. The intrinsic cognitive load, we need this, but we don't want to spend all our stuff on it. So one thing that helps is to use the same programming language for everything. I used to be all, use the language that suits the problem. Why wouldn't you want to use different languages for the front end and the back end? Are you lazy? No, I just want to spend my mental energy on something even more relevant to the business. Now I'm all about the best programming language is the one you already know and the one your team already knows. If that's good enough, stick with it. I mean, yeah, keep it up to date, be on a recent version, but one language is the best language because it reduces your intrinsic cognitive load. And finally, there's everything else. The extrinsic cognitive load is the stuff that your environment imposes on you or that your environment could take away from you and doesn't. So this is, filling out your timesheets, your health insurance forms. How hard is it to find a bathroom or know where the correct sparkly water is? More importantly, this is your build. This is your deployment process. Because yes, while it's essential that your software get to production, exactly how that happens is not intrinsic. So this is an extrinsic process. Who needs to review your pull request? Who do I need to talk to find out about this? It would be intrinsic cognitive load is how do I write a good database query that doesn't overburden the database? Extrinsic cognitive load is how do I get credentials to try this query in the database. And this we want to minimize as much as possible. So think of DevOps. In DevOps, you've got step 1, put all the people and knowledge and control needed in one team so that you can make change, find out what happened, make change, find out what happened. That's flow. Step 2, pull enough extrinsic cognitive load out of that team that team isn't 100 people anymore. It's like 10. So step 2 of DevOps is where we start reducing the extrinsic load by pulling it out. And DevOps is about doing that through changing system boundaries. One way we do that is to move some of the cognitive load from the people in the system down into the technical part of this socio-technical system. And we do that with automation. So just as our software has value because it packages up complexity, germane business complexity, in a way that's useful, automation packages up complexity in a way that's useful to us and moves it into the technical part of the system. And then the fun part is if you can share that with the rest of the team or then the rest of the company, then you've helped everyone reduce their cognitive load. So since this is like a technical conference, I thought I'd have some concrete examples. So here's something I wrote the other day. I could do this with a script, but I chose to do it in Slack. The problem statement is I have a bunch of these test repos hanging out in my GitHub org because I probably ran some manual tests and didn't run the cleanup step. So I want to remove those. So I wrote a couple of functions and ran them, or installed them in an Atomist software delivery machine. Atomist is a development automation platform, and one of the things is good Slack integration. So if I tell Atomist to clean up test repos, then Slack will not send the message because we're not on the Wi-Fi. Totally optional, totally optional. Forget it. I'll just show you what happened last time I did it, which is it asked me for my GitHub org, and then it called out to GitHub, found these, gave me a button. I can push delete. It'll tell me it can't connect because I'm not on the Wi-Fi. And then it deleted them. So that's like 2 functions that I wrote, and now it's available to my whole team. It's particularly, this is a trivial example, but that's okay. It's particularly important to automate things that you want to stay consistent. Okay, consistency is for machines, not people. And consistency keeps our code more malleable and changeable, so that's important. Put this stuff in automations. For instance, I used to work on the Atomist documentation, and I made a glossary, and I put all these words in the markdown, and then I wanted them to be in alphabetical order. I didn't want to put them in alphabetical order. I wanted them to constantly be in alphabetical order. So I wrote a function that pulls this, pulls in the markdown, parses it into words, alphabetizes them, throws it back out there. And then when I plug this in to the automation framework, the development automation platform, it just runs on every push and pushes the alphabetized glossary back to the repo. We use this for adding header files. We use this for updating the changelog. We use it for creating a legally required third-party licenses list that goes and gets all the NPM dependencies and all their transitive dependencies and their licenses and puts them in a human is not doing that. No. So I want to tell you a little more about that. That actually happens. I also wrote the delivery automation for the documentation, and yeah, no connection. I got it, you're fine. That looks like this. I'm not gonna run it because I'm not connected. Never count on conference Wi-Fi. So that looks like a commit came in and the automation responded by creating these goals. All right, yesterday in the keynote, Brian talked about, can we have like a generic integration and delivery concept where you just plug in the pieces that you need for your workflow and your triggering and your notifications and your approvals? Yes, yes, that is part of the vision of Atomist. So is having a domain model around automating software. Kubernetes is the API for hardware. Atomist has made an API for software. So is this idea, I mean, he called them workflows and tasks and steps. Atomist calls them goal sets and goals, and each of these, of course, runs in a Docker container, and it's not really a list, it's a tree, and this Slack message updates as it goes, and I don't have credentials for S3 set up, so of course that failed, it was supposed to. But this is entirely event-driven. It's a different way of a slightly different way of thinking about CI/CD because it's a little more centralized, which makes it easier for one team to keep it alive. In the sense of a push event among many others comes in, and something sets the goals. Each of the goals is an event. In this particular organization, Satellite of Love, if I push to any repository that has a makedocs.yaml, which is like this documentation generator thing, then my automation will respond by being like, I know how to build a makedocs site, and it does. I don't have to set it up per repository, and when I change it, it changes it for all of them, which makes it easier to keep them alive. All right, so that is how Atomist views CI/CD, which is very much in line with what Brian talked about yesterday. Then there's other things we can do. In addition to consistency, you want to put any sort of drudgery into the machines. So updating libraries is boring. And even finding out what you need to update is boring. But we can write code to do that because we're developers. So like, I wanted to find out, okay, which repositories have been updated recently? And I've got some code for that. So I wrote a function, or found a function, that given a cloned repository runs a git log to find out when the commit was, and then we can put that in a database, or we can rank it by like how recent it was. And then I ran, this is all open source, by the way, this local stuff, you'll see in a minute. Because if we go over the output of this, I ran it on Platform SH because they have a bunch of public GitHub repos. And then if I go over to the interface, it makes a cute little sunburst graph of some of them are recent, some of them are ancient, and some of them are prehistoric. This is fine. Sometimes it's really hard to automate fixing things. You can also do this. You can get a pull request on every repo. But I can automate detecting things. So it's things like, oh, well, how many repositories have a license? Some of them. A lot of them don't. You can detect things, and then if you want, you can automatically change them. And you can tell this is open source, and the interface is really ugly, which I can say because I am responsible for that. This is fine. I'm not a front-end developer yet. Yeah, so there's things that we can do in code to make some of that drudgery easier, at least identify our problems. And then the other thing that you want to do is not have to wait. So if I do, and I can, on the Atomist as a service, I can run pull requests across all these repositories to get them up to date, and then you have to see whether they succeed, and maybe you have to wait for approvals. All that waiting is way overrated. Back to the slides. There's a beautiful post I saw the other day about, do it? No, PowerPoint. Oh, I miss my Mac. Let's try that again. Please show this slide. No, the one that I have selected, please. Maybe not. I don't know how to get it to show the one I have selected. I really, really miss PowerPoint. Fuck. Anybody know how to work PowerPoint? Okay, I'm gonna exit it. This is not a problem I've had before, this is fine. Okay, I'm going to talk about a post that Gil Navarro made the other day, and his company, Adovinta, they have a platform team, and they made all these developer automations, and in order to do that, they needed to be able to respond to events in the delivery space. Yes, that one. Okay, right, so this is his picture. And so he built this like event hub for all these different events that are important in software, and he called it the dev hose. I like the name Atomist a little better. But this is great. The DevHose is an event hub. And yeah, you need this because I hate waiting for builds. And I hate even more waiting for pull request reviews. And I need those notifications, and I need my automations to run. So Atomist builds that event hub for general use. That is totally in line with what Brian talked about yesterday. So consistency is for machines, drudgery is for machines, and waiting is for machines. But the more of this that we put in code, the more code that we need to keep alive. I mean, this stuff needs to not die too. I don't want to be infested with zombies in my software development. So what do we do about that? Well, team topologies comes in here again and points out that you can have a platform team. You can offload this extrinsic cognitive load into one team, and that can serve multiple it calls them stream-aligned teams that are focusing on that germane cognitive load and making business software. Awesome. And this has to be as a service, because as soon as there's any sort of handoff to the DevOps team, you've broken step one. You've broken the flow of all the control being on a single team. So this is about step two, pulling off extrinsic load, but don't mess up step one. It has to be as a service. And so then you wind up with a bunch of business software that you're growing and keeping alive on top of a platform that you also need to grow and keep alive. Except, on top of the world, on top of like everything offered by the rest of the world. So there's your cloud providers and your Honeycomb and your Humio and yeah, everything outside the company, which is the best place to have that cognitive load, by the way, is outside the company. And then, do you really want to keep that platform alive? You don't. You don't actually want to keep this platform alive. You want to continue adding what the stream-aligned teams need while maintaining less and less code. You want to thin that platform out as the world gets bigger. So as Kafka as a service gets strong enough for you to use it, and managed Kubernetes is good enough, and maybe Gallo can lose DevHose and build it on top of Atomist instead. That is software that someone else is keeping alive. Someone else is taking that problem really seriously, and you want to use their stuff. So yes, kill off your platform code as quickly as you can, push that onto the rest of the world, pay someone else to think about that stuff, and to keep it alive and to keep it growing. That is what you want. There is value in killing off software. Just don't keep it out there as a zombie. Yesterday, I got an email from Sonos. Sonos was like, we're finally sunsetting this hardware, these speakers that I've had for 10 years. Easily 10 years I've had these things, and they've been updating, so they run on the latest service this whole time. And finally, Sonos is like, look, there's not enough memory and processors in those old Generation 1 things. Here's a discount on upgrades. Great. Linda says, cool. Take my money, Sonos. You get it. You keep your software alive, and when it's dead, you acknowledge it as dead, and don't try to pretend I'm still going to be able to use the latest services on it. So done is death, and death can be beautiful. Death is renewal. The software that's still in production, let's keep it alive as much as we can. And if that gets boring, don't do boring work. Step back and think about it at a higher level of abstraction and see how much of that you can automate. At least detecting where you can make changes. You can automate that, and trust me. I mean, best case, you succeed, and you get less work, less boring work. Worst case, you find out that that's actually a lot harder than you thought it was, and it is not, in fact, boring. And your work of coding, you gain more respect for it when you try to automate it because you understand it even better. The end. There's a write-up for this talk on my blog already at blog.justitron.com. And you can find me on podcasts and Twitter.
Great job. Round of applause, please. So Liz was up here first. Let's start off with you.
So that was an amazing talk, and I wish more people would hear it, because every single month a unicorn company approaches me and says, hey, Liz, we would like you to build our observability platform from scratch. We promise there is no technical debt here. And I'm like, no, run less software. What can we do to get people to actually not write more software?
Move this way, please. But it looks like you had a follow-up?
Oh, to not write more software? Well, I do have a rant that if you think you can write the software better, it's because you don't understand the problem space. So don't be lazy. Look at someone else's software and try to really understand it.
I'm just here because I have a problem.
Excellent. We want to hear about it.
So I told my team I'm going to come to this conference, and they said, oh, no. I said, yeah, I want to automate some tests and do some stuff. And they're like, oh, no, you don't want to do that. You don't know. We won't show you the stuff. So I'm just wondering if anyone's had success of getting people to just open up and talk about what tests they have and what their system is doing when they don't want to because it's embarrassing and old and there's multiple programming languages involved?
Yeah, I mean, I've been doing that for 20 years. It's a matter of finding a way to communicate with people in a way that doesn't say you suck and you're failing. You have to find a way to, and sometimes this might seem almost false, but say, oh, you've done that? Okay, yeah, that's great, you know, and don't, because like I know when I love testing, I can be very over-eager about it, and if I come in and say, no, but you could do this, and you can be doing this, and you can be, if you do that, you're not going to get anywhere. But I just wanted to bounce back on what you were saying about don't recode something, and it might be because they don't understand what's underneath, and I think there's a problem there, and I'm not sure what the solution is, that often when something is automated to the point that it almost disappears, the people don't understand what it's doing underneath. And if they don't understand what it's doing underneath, then they might misuse it. An example more on the coding level is there's so many tools that, for example, generate SQL. If you don't understand what SQL does and how it does it, your automation, you're going to misuse that automation, and you're going to have really crappy SQL code.
That's actually on the same point of the challenge I was going to say is how do you revisit? So we talk about the fact that you can game metrics, and so the best metrics come and go as you like learn from them, and as you have gained value from them, you then change what they are. So I'm in testing, and so I will sometimes identify a risk, and then we'll talk about it a lot, and we'll automate some stuff to be able to help us. But then how do we come back and revisit? Is that still the thing that's catching our risks or not? And that. So yeah, how do you come back around and check on your automation of stuff is I'm curious about.
Yeah, and this is, if you ask the question, and this is not a question that we ask our teams yet, what have you learned about how your software works lately? Because you can teach the software to tell you that. I have another talk called Principles of Collaborative Automation that looks into some of that. Because, yeah, the software has to tell you how it's doing. And if we're going to learn from it, we have to come back and look at that stuff. And if you just implement something and then never come back and look at it, it's like buying a lottery ticket and throwing it away.
Yeah, that's actually going, when all the time that people have been talking about pipelines over the last couple of days, the problem is most people see the pipeline as unidirectional. It's going from development into production. What we need are the pipelines that then feed back into it. And there's something, a colleague of mine wrote this whole paper to send to a customer the other day, and I basically said, so basically what you're saying is, if we're going from A to B, we can't actually know we're going to get to B because we have to stop along the way to figure out, are we still going to B or not? And actually, we might change our mind and say, no, we don't want to go to B, we want to go to B prime. You know, it's like you have to have the continuous feedback of what you're doing and how you're going to get there. Otherwise, you might actually get to B and it's going to be wrong.
So I wanted to answer Lynette's earlier question, which was the kind of subject of how do you get to walk alongside people rather than kind of kind of delivering, hints from above. One of the worst mistakes of my software engineering career was I parachuted onto a team and said immediately, you're doing X wrong and Y wrong and Z wrong, and they never trusted me. Like, they just never trusted me, and for good reason, right? Like, you kind of have to sit down and pair with someone to understand their process. Like, you're not going to get that data unless you actually spend time investing in that relationship.
One of the areas that we struggle with is that it's very easy to build tooling and automation to start new projects. It gets a lot harder already to build tooling around maintaining projects, and it's very hard to build any kind of automation about removing or decommissioning projects. As a result, we have like hundreds, if not thousands, of services running. Most of them would be in the ancient category of the slides, and more or less they don't cause issues most of the time, but it becomes more and more of a maintenance burden, and long term, really a drag on the organization. It's like we have a lot of automation around automatically updating libraries and things like that, but there is still somebody needs to go look at the pull request that was created and kind of make an assessment. Okay, I can safely merge and deploy this thing, and then hope the deploy still works, right? So this is definitely a thing, and more investment and kind of frameworks and ideas about how to get rid of software would be very welcome in our organization for sure.
So more to address what you were saying, Lynette, was I used to be a compliance auditor, so I'm your best friend, but I'm a really outgoing person. And if you start talking to people and you ask them questions and go along your journey of finding out facts about what's happening and what they document, how they document things, you'll learn about all their systems and their tests that they run, where they run their tests from, how often are those tests failing. You'll learn that tests that are supposed to be mission critical haven't been running in 6 months. You'll see all that stuff, and then you can ask them good questions about why do you do it this way, and if it's really mission critical, why haven't you run in 6 months and no one's complained?
I think one of the fears about using automation to manage complexity and work at a higher level of abstraction is that if you are creating internal abstractions and you still own the underlying complexity, you haven't solved anything. You've just created a wall between the end user, the developer, and that complexity. And so abstracting complexity via automation works well when you're moving that complexity externally to a platform like Atomist, or run your app on Heroku. But if you're just creating abstractions and you're still responsible for the underlying complexity at some level in your org, you're not really moving the needle.
I think if you centralize that complexity with one team, so that one team can take care of it, rather than everybody needs to kind of know how things work, that is definitely a win in my book.
Actually, I disagree with it. I think that I've tried this a couple times. I haven't been able to convince anyone to do it, but I think there should be a certain rotation of visiting people to different teams, so that because like I said, this in DevOps means everybody needs to understand to some extent what everybody else does. And the only way to really, sometimes that happens naturally when people from different teams have to work together, but maybe it might not be a bad idea saying, okay, I'm in the invoicing team, I get sent over to a completely different team that interfaces not directly, but maybe 2 steps down the line with what I do, so that I understand what I'm doing impacts what they do.
I saw one good implementation of getting someone. Unfortunately, somebody ended up getting fired for not creating any code. And what they later found out was this person was getting calls from customers and breakages all day. And so they had to change, and then someone on the team became Batman for the week, and they had to take all the incoming problems for the week and learn how to fix them, and it became rotating. And it was terrible that somebody got fired for no reason that wasn't their fault. But what they learned from it is there can't just be one person who's taking all the incoming drama. There has to be different people on the team who can do that.
So I want to challenge a little bit the platform concept because this is how we got legacy. Because what happens is when you create a platform team, eventually they start cutting the problems in the same way that we're cutting the problems in our software. So they have abstractions that they will build in order to build things, and then they will cut at another platform team and another platform team. So when we go to enterprises, what we see is multiple levels of indirection, and that platform teams essentially become help desk teams and ticket migration team. So a ticket comes in, they say, I need this data shoved from here to there, and then the person shoves the data from here to there, and they have no idea what it is, what it's for, where it's coming from, where it's going. And then it ends up creating a lot of this inertia. So one of the things that, at least in the data space, that we try to do is limit the number of platforms that sit in between the sources and the destinations of things. So you might need one team to help enable, but when you have multiple, then you just get, it ends up growing horizontally away, which is not in the direction of your use case.
I think it's a function of size and scale, really, where if you are a small startup, it's relatively easy to stay on the same page. As you experience hypergrowth, people wind up having their own ideas on how you do things. Eventually, you wind up with, 20, 30 different ways of doing the same thing. You eventually have to agree, in one way or another, this is what we're agreeing to maintain and build together, and either you do it with one team or everyone pitching in. And maybe you have 3 solutions, but not 20 solutions to the same problem at a company the scale of Google or Shopify, right? And I think that, to Emily's point about toil, the SRE concept of saying, we're going to cap our amount of operational load to 50% is really, really powerful. And this idea of, rotating who is doing the operational work is really, really powerful for making sure you don't fall into those ruts of just routing things from point A to point B.
So let's move on to the portion of if we had a magic wand and could change things and see these results in 2 to 5 years, what would they be? Software upgrade on people?
I kind of hinted at it already, but I think there is a lot of tooling available to kind of get set up and get going, and more tooling focused on maintaining and eventually deleting stuff that is no longer useful. That would definitely move the
What are you thinking of for tools that automatically clean up stuff?
So one concept that we have is different tiers of services. If you're in the lowest tier, there is basically we say it's it can run for 90 days, and after 90 days, unless you say I want it to run for longer, we will shut it down. Just to kind of people thinking about it's okay, is this if this is more important, then we should probably upgrade to a higher tier and do some more work to make sure it's in a maintainable state. So that's one of the things we did. It's still very hard because it's so easy to just press the buttons I want it longer than 90 days. So it doesn't fully solve the problem, but it's an initial attempt at this problem, I think.
Very nice. Other ideas?
I think one of the things that we struggle at as engineering teams is figuring out how much time are we spending on things, right? I spent 5 minutes or 10 minutes or, 20 days hacking together this thing, right? To actually have people be consciously aware of this is the opportunity cost that we're paying, right? I think that would help us better make those trade-offs on build versus buy. And that's what I'd like to see in the next 2 years is engineers being universally aware of this is the cost of my time.
Yeah, no, I definitely agree with that. I try to advocate that for all the time for our executives to understand, hey, there are products that can help solve these problems as opposed to us building it. And the time that it's going to take for a dev team to work on this, that's not our vertical. We should just buy this product. For example, Slack. We could build our own real-time chat messaging system, but there's Slack, and it makes everyone happy.
I would love if platforms were a little more extensible, because sometimes you don't adopt a particular vendor or a particular solution because you're not sure if it's going to scale for you, in part because they don't have good interfaces or good guarantees about extensibility. And sometimes you end up solving something for yourself because then you know you're going to have more flexibility. So it would be very nice if there were more powerful platforms out there for delivering software, for running software, and for everything in between.
If nothing changed but performance got better, it would make everything better.
I want to have retirement parties for software.
Who's buying the cake, though?
The business that doesn't have to pay for the business doesn't have to pay you to support it anymore. They should totally buy cake.
I want to see better tools for, again, I'm going to go on the data thing because I'm a data person, but better tools for incorporating the data that we have into our build systems. So if I have instrumentation that's looking at how an app is being used, there's no reason that I can't take the actual data stream for that app and integrate that into my build pipeline and be actually, you don't need this feature. We don't care. Nobody's clicking this button.
Yeah, from what you were saying, for example, if there's some service that's out there and there's a monitoring tool that shows that that service hasn't been touched in X amount of time, there should be a way to at least send the alert back saying, we're going to cut this code out. Or even you could send it back and automate bringing up a test environment, running through the set of scenarios without that particular service. Hey, this still works and there's nothing there.
Yeah, I think one of the interesting things, similar to we shut it down after 90 days, is we will refuse to run any code that has not been built in the past 90 days, right? That is a thing that Google actually did. It's called Build Horizon, and it is amazing, right? It means that you don't have zombie code. You don't have code that cannot be patched, because everything by definition was built in the last 90 days.
I will say that one thing that we should be careful of is that as we start talking about closing feedback loops, I think you mentioned like wanting to tighten up and close the feedback loops in our automation and our processes. As soon as we close that loop, we create a closed loop dynamical system. And there can be interesting effects that happen. And so even if something looks like it's not doing anything, if it's in a steady state operation, you can remove it, and then it has weird effects. Yeah. Right? So it's something, like, I think that we need to get a lot more clever about how the sort of chaotic nature of our software development and delivery actually works.
That's a perfect example of where, because if you come from data, in any given scenario, there may be edge cases, not in terms of over this limit or under, but just edge cases in this only happens once a year, but the code has to be there because when it happens, it better fucking work.
Yeah, like if you have like this delete this after 90 days thing, but I'm a medical device manufacturer, right? And I've deleted the code because it's not been changed in 90 days, and then the FDA auditor comes 180 days later, there's a word for that, and that's you're fucked.
I think we're really good at notifying when things do happen, and we could be better at notifying when things aren't happening more accurately. For example, we can tell if someone's opened a file, but can we tell if anything else has called that file from somewhere else? Because I can't always tell, and I want to know, because that would tell me, has it really been used in 90 days by anything, not just has it been opened by a person. Is that solved already, and I just don't know about it?
No, I don't think that's solved already. So we're just about on time. Thank you very much. I've really enjoyed this follow-up conversation, but it by no means have to end. Lunch is available next door, but we've got a whole hallway, and this room is available for the next hour until the next speakers begin. So thank you very much for joining us. Can we get another round of applause for the speaker? And for the conversation as well?